All right, so here's another Khan Academy problem. It says, in its early days, the International Space Station had a mass m. This is the space station right here, space station, and orbited the Earth, right? There's the Earth. And with a radius r and speed v naught and a period t naught. So period is the time it takes to go around once. More modules were added to it, which led to a four times increase in its mass. So the space station is getting more and more massive as they're tacking on more and more parts to it. So intuitively, you might think that that would slow it down or something as it orbits. So in the previous video, we derived this equation right here. When an object is orbiting, the velocity of the orbit is completely dependent upon three things. The gravitational constant, the mass of the object that it's orbiting, which is the Earth, which does not change, and the radius of orbit. Now, you can't change the gravitational constant, and the mass of the Earth isn't going to change anytime soon. So the only thing that affects the velocity of the satellite as it's orbiting is its radius of orbit. So if you don't change that, you don't change the velocity. So even though they've added more mass to the space station, that does not affect how fast it's orbiting. And if the velocity doesn't change, then it's going to take the exact same amount of time to go around, and therefore the time period does not change either. So the question says, what is the new period t in terms of its original period t naught? There is no increase or decrease. It's just simply t naught is exactly what it was. The only thing that would change its radius of, the only thing that would change its time period and its velocity would be changing its radius of orbit.